A vertical asymptote of a function is a barrier that the function cannot actually reach. In this case, we're looking at the line x equals 5. This barrier forces my function to either approach positive infinity or negative infinity. So as we are coming towards -5 from the left-hand side, y is going to positive infinity. But as you approach this barrier from the right-hand side, your y value is going to negative infinity. Anytime I have a vertical line where my y values are either going to positive infinity or negative infinity, we call that an asymptote. When we were looking at odd power functions with inverse proportionality, we notice that all the graphs had this basic shape to it. In the first quadrant and in the third quadrant. And we noticed that as x approached 0 from the left, y was going towards positive infinity. As x approached 0 from the left, y was approaching negative infinity for all odd power functions that have inverse proportionality, meaning every one of those have an asymptote at x equal 0. F of x equals 2x minus 3 divided by x plus 7 is called a rational function. Now, a rational function will have a vertical asymptote anytime that the denominator can be set equal to 0. For instance, when we were studying the domain of this function, we knew that x plus 7 could not equal 0 because dividing by 0 is not defined. This allows us to find out where the vertical asymptote is. By subtracting 7 from both sides, we're able to determine that our domain is all real numbers but -7. Why not -7? Because -7 is a vertical asymptote at x equals -7. If I was to graph this, you would be able to see that the graph never actually crosses the x value at -7. I'm now going to use my calculator to graph the function y equals 2x minus 3 divided by the quantity x plus 7. Now, I'm going to do a zoom standard, which is going to set my x min to -10, my x max to +10, my y minimum to -10, and my y maximum to a +10, and hit enter. Now, over here at x equals 7, you'll notice that I don't cross that part of the graph. I'm going to zoom out to get a little bit better look at this. And notice, as I approach from the left, my graph shoots up towards positive infinity. As I approach from the right, my graph shoots down to negative infinity. If I try to push the trace button and enter number 7 for my x value and hit enter, -7, and hit enter, you'll notice it does not produce a y value because that's not in the domain of the function. I have that barrier, that vertical asymptote at x equals -7. One thing we have to be cautious about when we look for vertical asymptotes is to make sure that the 0 in the denominator does not cause a 0 in the numerator. For instance, if I was to look at the denominator, x squared plus x, and I was to analyze my domain by saying that that cannot equal 0. Well, in this instance, I'm going to have to factor to solve for the x values. I can take out a greatest common factor of x, leaving me x plus 1 cannot equal 0. I can now set each one of those factors equal to 0, or actually not equal to 0. And I end up with x cannot equal 0 and x cannot equal -1. So my domain is going to be all real numbers. Let me go ahead and write that. My domain is going to be the set of all x where x are any real numbers, just not 0 and not -1. This is very true about the function. However, both of those do not produce a vertical asymptote. Let me notice that when you plug in the 0 into the function in the numerator, I would end up with 0 squared minus 1 over 0 squared plus 0. The numerator produces a -1. The denominator produces a 0. That tells me that this is undefined, and I know that x equals 0 is a vertical asymptote. However, when I plug in -1 into the numerator and denominator, I end up with something a little bit different. I actually end up with a 0 in the top and a 0 in the bottom. There's a reason why this does not produce a vertical asymptote, because this tells me that I could have reduced my fraction. If you will notice, f of x on top is x squared minus 1. That can be factored to x minus 1 times x plus 1, because that's a difference of perfect squares. On the bottom, we already factored it here. If I write that as my denominator, this fraction reduces, giving me f of x graphs the same as x minus 1 over x. Few things to note. That tells me my only vertical asymptote is at x equals 0. However, x equals -1 is still not in the domain of the original function. Okay, I'm going to be looking at this function here and determining if it has any vertical asymptotes, and if so, what are they? First thing I'm going to do is start by looking at my function and factoring the denominator. When I factor the denominator, I will get x times x squared minus 1. I notice that this function is now reducible. So f of x is the same as 1 over x squared minus 1. I will now take that denominator by itself and note that that value cannot be 0. Or x squared cannot be 1, x cannot be plus or minus the square root of 1, which is plus or minus 1. From here, I now know that I have vertical asymptotes at x equals -1 and x equals +1. Very important that I reduced this before I came up with